Hello everyone, super excited to be here again with Dr. Satchin Panda, who is a professor at the Salk Institute for Biological Sciences. And this is actually a round 2 podcast. Previously, Satchin and I had a really long and interesting discussion on his research and how we talked a lot about how the body's internal clock, which is known as a circadian rhythm, how that is regulated by the external cues such as light, and how the interaction between light and a certain part of the brain called the suprachiasmatic nucleus, which is like the master oscillator, as it's called, or the master regulator of circadian rhythm, and how circadian rhythm regulates, when we're active, when we sleep, when we're awake, when we eat, things like that. But also we talked a lot about this other external cue, which also regulates circadian rhythm in what's known as peripheral oscillators, which are other tissues outside of the nervous system, such as the liver and the gut, and how that's actually regulated by the timing of the food that we take in. And that's where Dr. Panda's work comes in, has shed a lot of light on what's called the timing of the food intake, and how restricting that timing of your food intake to a certain period of time, for example, 9 to 12 hours during the day, can possibly affect a variety of different metabolic outcomes and health factors. So his research in animals has shown that animals that are restricted to eating within a 9 to 12 hour window have improved glucose metabolism, improved lipid profiles, improved cholesterol, increased lean muscle mass, decreased fat mass, decreased fatty liver, favorable gene expression patterns, all sorts of really favorable outcomes. In addition, he's also shown that when these mice are fed what would be sort of analogous to, I think, the standard American diet, which is like high in sugar, high in saturated fat, just not a really good diet. If they are restricted to this narrow timing, feeding window, which is 9 to 12 hours, they still have improved markers of metabolism and metabolic function, and which is really hopeful in a way, because I think it also indicates that there may be some possibility that for people that have a really hard time eating healthy or just don't eat healthy, maybe even just doing this one thing where obviously we want them to eat healthy, but if they don't eat within a certain time window that's more restricted, possibly that would have favorable outcomes. So I'm super excited, Dr. Panda or Satchin. So just sort of, since we're talking about this, do we have any human evidence that the people that have, for example, like metabolic syndrome, if they eat within a time-restricted eating window, there's any benefits to that without changing their food composition?
Well, historically, most of these research studies haven't looked at timing per se, but there was a very nice comprehensive review published by American Heart Association, who went back to many studies where timing, or at least how many times people ate during the day, was recorded. And after compiling all the studies, it was close to 70 or 80 different studies related to fasting, nutrition quality, how many times people ate. They found that yes, limiting food to a certain number of hours during the day or maintaining overnight fasting was beneficial for cardiovascular health. So that's a very well done meta review of existing literature. What we need to do now is to look for new studies where this is specifically looked at, where everything else is kept constant and timing is changed, so that we'll see whether the benefit is seen among individuals who already have metabolic syndrome. Mm-hmm. So that's what is lacking in the field. And as you know, this is a very new area of research, and NIH funding cycle is 5 years. So any of these studies will take at least 5 to 7 years before we see any result in peer-reviewed journals.
Yeah. Particularly for, I guess, a clinical trial, if you're actually looking at someone with metabolic syndrome. Probably obesity, if the person's obese, it may take a little more than just time-restricted eating to lose weight, although they may lose some. They may require more of a prolonged sort of fasting, but the time-restricted eating certainly would affect I would predict would affect their metabolism.
Yeah, so what we see in our study, a small study that was published, and also some of the other studies that may be in the pipeline, are when people adopt a time-restricted feeding paradigm in their regular life, in real life, not in the laboratory condition or in clinical trial, then they naturally reduce their caloric intake without even counting calories. So for example, when they stop, suppose that they target to stop around 6, 7 or 8 o'clock in the evening, then the late night snacks and then the late night glass of wine or beer that used to be their usual habit, they stop that. So in that way they are doing two things. One is reducing calories and also improving nutrition quality, because that extra energy dense diet is not getting into their system. Okay. So in that way I'm hopeful that we'll see some weight loss and then some improvement in real health, blood biomarkers. And in rodent studies, what we have seen, when we take already fat mice who have been eating really unhealthy diet for long period in their life and then put them on time restricted feeding paradigm, they don't become like lean mice in terms of body weight. They become overweight, not normal, but surprisingly they're biochemically or physiologically they are more healthy, because the blood biomarkers for glucose, cholesterol, triglycerides, they come back to almost normal range. So we have to make that distinction that some people may not lose a huge amount of weight, but they might actually see benefits in their metabolism and physiology. So that's one thing we have to look out for.
But this is the mouse study you were just referring to. Yeah. They were still fed a poor diet.
Yeah, they're still fed a poor diet, isocaloric diet.
So imagine if they were fed a better diet. And the obese mice were fed a better diet, and they were doing time-restricted eating.
Yeah, so they will be much better.
Much better.
They will lose more fat mass and become much more healthier.
Can you explain for people who just aren't very familiar with time-restricted eating or time-restricted feeding, as we call it with animal research, like just what is that and how does that actually affect your metabolism of glucose and fatty acids and amino acids?
Yeah, so let's kind of step back and ask how does it relate to circadian rhythm or the daily rhythms. So if we think of our daily health, our personal sense of how we feel healthy changes from time to time throughout the day. So for example, in the morning when we wake up, being healthy means you're feeling much rested and you're full of energy to start the new day. You're feeling actually much lighter. You should not feel that full stomach or grogginess, and have a good bowel movement. And then throughout the day, being healthy means not feeling too hungry, so having some food in your system, and then being productive throughout the day. And then towards the end of the day, being healthy actually means having taken a walk or something, so you're not feeling really, you haven't moved all day and you're not feeling that sense of being constrained in a place. And at night time, before going to bed, being healthy means feeling really sleepy, so that as soon as we switch off the light and get into the bed, we fall asleep. So in this way, you can see that the being healthy, this definition is very different at different time of the day, and a lot of it actually has to do with physiology or metabolism. So in morning, feeling lighter and not groggy and not having a food hangover means you have already gone through, hopefully somebody has gone through 10 to 12 or even 14 hours of fasting or not having food in the system, so that your body has metabolized all the food and has processed it, and your gut has also gone through rest. And then towards the end of the day, when we are going to hit the bed, if we have food in our system, what happens is our blood flow is directed towards our stomach to digest the food and absorb it, so core body temperature remains high. So not having food for 2 to 3 hours before going to bed actually helps us to go have that deep sleep, sound sleep throughout the night. So in this way, now if we back calculate and think, okay, so when should we eat? So then it makes sense that, well, after waking up, maybe give 1 or 2 hours, before we start eating, and then before going to bed, at least 3 to 4 hours, depending on what your metabolism, 2 to 4 hours before going to bed, we should stop eating. So that brings up the eating window of, say, up to 10 to 12 hours max when we should be eating, so that we have that personal sense of being healthy throughout the 24 hours. So in animal studies, what we have done is we ask a very simple question. If we take animals and give them food just like most labs do, they have food in the hopper, they can eat whenever they want, and we calculate how many calories they eat. And then we take another group of mice and then give them the same number of calories and from the same source of food, whether it's high carb, high fat, high fructose, doesn't matter. We have to give the same source of food, same number of calories to the second group, and they have to eat all that food within 8, 9, 10 or even 12 hours. Then we consistently find that the mice that eat all their food within this 8 to 12 hours window are healthier than ad libitum fed mice. So that led to the term what we call time restricted feeding, where the timing of food when you eat is restricted, or you define it and stick within it, not caloric restriction, where you have to count calories and restrict it. So in this way it becomes very easier, because you just have to, we all know how to manage our time on a daily basis. We are always dealing with time. So it becomes easier, because if we start eating around, say, 8 o'clock in the morning, and based on our lifestyle we can do 10 hours eating, then I'll have my dinner, say, around 6 o'clock. Mm-hmm. So that's the concept of time restricted eating or time restricted feeding.
And yeah, I think that having the time where you just sort of say, well, I should stop eating by 6 o'clock, or kind of having it so you don't have to constantly each day think about it, like, when did I eat my first meal, or when did I take my first bite? If you kind of just have this general schedule where it's like, at least during the work week, it's easier.
And then another thing I must point out, that in our animal experiments, when we do these experiments, suppose say we say 8 hours, we put the animals for 8 hours. And then every week we measure their food intake, and some weeks they might eat less, and then we immediately change that schedule to, say, 8.5 hours or 9 hours the next week, to make sure that they actually eat the same number of calories. So moving this needle by 1 hour actually is not that detrimental. It still gives them the benefit. And we have also asked another question. So in animal experiments, in weekend we let them free, they can eat whenever they want, and they definitely go outside even 12 hours window, they eat almost throughout day and night. But still that 2 days of binge eating can be counteracted by if they stick to 8 to 9 or 10 hours during the weekdays. So that also gives us hope that perhaps in humans occasional eating, maybe once or maybe maximum twice a week can still be tolerated.
That's good to know. I guess a lot of people would be happy to hear that.
Yeah.
What do you do? So for your typical work week and then weekend schedule, like, what's your time eating window? And
yeah, so it's I travel a lot too, but what I have found is if I stick to maximum 12 hours window, then I actually feel much better. I'm more energetic, I sleep well, and I feel lighter, and I'm still productive throughout the day. So I start, say, somewhere around 7 or 8 in the morning, and then I stop around 5 or 6 in the evening. And I also try with different types of diet once in a while. One thing with many people who are new to time restricted feeding or eating or feeding is when they started they feel hungry, and what we have found is, well, having a fiber rich diet or a protein rich diet or a slightly higher fat rich diet actually helps to go through that longer time without food, and slowly you also get used to it. And all of these actually increase your nutrition quality, because you're staying away from simple sugar and high glycemic food, and you're leaning more towards food that takes longer time to digest or longer time to absorb. So that helps. So in that way, my diet, both diet quality and also the duration has changed. And I usually stick to 12 hours, and in many cases, I kind of try to stick to 10 hours. If
me too. I try to stick to 10. You're talking about the people feeling hungry when they first try this out. Has anyone ever looked at how time-restricted eating affects satiety hormones like leptin or ghrelin, which would be the one that makes you hungry?
Yeah, so we haven't looked at that in humans, but in mice what we see is all of these hormone levels, they come back to more homeostatic range. That means they don't go too high and they also don't go too low. So that was kind of surprising, because we thought that the hunger level will go up and the hunger hormones might go through the roof. But somehow after a few days the body adjusts to it, and then it keeps them in a homeostatic range. And also humans who do it, we do see that after 2 to 3 weeks the hunger at bedtime is pretty low. They don't feel hungry. They might feel actually lighter and ready to sleep. So then they realize how it feels like to go to bed with a lighter stomach than with a heavier stomach.
And then once you actually, if you break that time-restricted, eating or feeding window, I've noticed, at least in myself, you actually start to feel worse. Like right now, I'm 37 weeks pregnant, and throughout my pregnancy, I've pretty much thrown my TRE, my time-restricted eating, out the window. Well, I do 12 hours, but usually I do 10. I try to do 10, sometimes 9. Particularly if I'm going to go for like a run in the morning or something that's endurance related. I like to eat within a shorter time window. But there are times that I can't even do there have been times throughout my pregnancy that I can't even do 12 hours, and I eat a little bit after that, and I do notice it affects how I feel. I feel more lethargic the next morning.
So there is this food hangover that stays with you. It's almost like, as if the food stayed there in the stomach. It didn't get digested, or the stomach was sleeping when the food came. And we get that response from many of our users, app users. That
from My Circadian Clock.
My Circadian Clock app. There are many times when people, usually what happens is, for the first 2 to 3 weeks, people are very diligent. They try to do it, and they get into that rhythm. And then we get this occasional feedback around week 5 or 6, when occasionally they felt like they could go out late at night and eat, and then next day morning they felt horrible because they were feeling so lethargic, so groggy, and then they email us saying, wow, really, it felt like our stomach was really sleeping, and I'm not going to do that again. Because so it's kind of interesting that hits around week 5, 6, 7, when people think that they have adapted to a lifestyle and they are doing okay, and maybe they can occasionally eat outside the window, and they do that late into the night, and then the body reacts, and then they recognize that reaction.
So for people that aren't familiar, the My Circadian Clock app can be found on the website My Circadian Clock, and it's basically your crowdsourcing data. People that want to try this time-restricted eating out can try it out, and also send their data to you and take pictures of their food, so that you can gather data for your clinical study, your study. So that's kind of a neat thing that people can participate while they're trying this out. Why not contribute to science?
I mean, what we realized is, even if we get the best funded clinical trial grant from NIH or DOD or any funding source, most of the clinical studies are done with people who live within 20 to 30 miles radius of a clinical center. And so in that way, even if we foresee there will be 5 or 6 clinical trials in this country, there will be only 5 or 6 of those centers, and people who are living within that 20 to 30 miles and have time and energy to travel to a clinical center, spend almost half a day in every 2 to 3 months or 2 to 3 weeks, will participate in the study and will see the benefit firsthand. Then we realized that in that way, most clinical trials which are low risk like this one, are actually will benefit or will sample a very small fraction of people. So that's why we came up with this idea that if we have a study that's approved by our ethics committee and we make sure that we maintain the privacy of people, we don't sell this data, we don't share this data with anybody else, and we give that assurance up front, then we may be able to recruit or enlist participants who are not living within 40 miles, who don't have time to come to a clinical center, but are willing to share their data for science. And they can live anywhere in the world, they can share their data. And in this way, this has been extremely useful because, again, in any clinical trial, if you look at the exclusion criteria, that is such a long exclusion criteria that only 1 in 50 or 1 in 100 who even shows interest in participating, they can participate. But if we take that result and then try to disseminate to the rest of the people, those 49 or 99 people who could not qualify, then how are we expecting that this will be applicable to all of them? So it's kind of a conundrum. So that's why we thought, let's try this way, where the only exclusion criteria is if you are below 21, because that's an NIH mandated exclusion criteria. And in this way, not only we can see whom it will benefit, we may also see whom it will not benefit. So we can actually a priori figure out what are the limitations of TRE. And people who don't qualify, for example, shift workers, they're mostly excluded from many clinical studies because of the nature of their work. They cannot come to the clinic at the right time, and this is more relevant to them. So now we have thousands of people who are shift workers and they're trying this. And from them, we are also learning what they can adopt and how they can adopt this TRE into their lifestyle, and whether it helps them with alertness, being on the job, and whether it helps them to sleep in the weekend and all that stuff. So that way, this has been extremely useful to have this kind of study. And sometimes we even get responses from our users that we had never thought about. So we take that response and say, hey, can we do this animal study and see what is going on? What is the biochemical basis for this? What is the physiological response in animals? Maybe that's how we can address. For example, there are many cases, there are many immune-related disease, and people report that these immune-related diseases improve under time-restricted eating. And that was surprising for us. But then we went back to our animal data and we realized that, yes, we actually see systemic inflammation goes down with time-restricted eating. And that makes sense. If the systemic inflammation goes down, then many immune-related or inflammation-related disease would also go down with time-restricted eating. So there are some examples like this where our human participants tell us their story, and if it is 1 or 2%, we may not take seriously, but then when it's 4, 5, or 10 or 15 people telling us the same kind of story, for example, many IBS patients who have irritable bowel syndrome, who have been going to toilet for 5, 6, 7, 8 times every day, they do TRE and then they immediately see that the number of times they go to bathroom has gone down. It's a huge improvement for them. And then we might hear this story once or twice, we may not take it seriously, but then if we hear it 5, 6, 7 times, then we start thinking about, okay, let's go back to our animal data, because from all these animals, we have collected every tissue that's imaginable, and we have a freezer full of tissues, and then we go back and test what might have changed, what might be changing in the gut, what might be changing in the intestine. Did the microbiome change? Did the interaction between microbiome and the host change? And that helps us to come up with newer hypotheses and do more focused studies. So this has been extremely useful for people to go sign up on the My Circadian Clock website and then download the app and share their data and also share their experience.
Wow, I just love hearing. There's so many things that you brought up that I have marked in my head to talk about, but first of all, to speak to your point, this is really, I think it is extremely important that you're gathering all this data from people without all these limitations aside from the age limitation. Like you said, you're getting the shift workers. I mean, this is hugely relevant for shift work, and and people that have IBS, people that have multiple sclerosis. Obviously, people that have certain conditions are probably consulting with their physician.
Yeah,
but
they do.
But still, you're getting this data, and then you're seeing these trends when people start to say these things over and over, like, "Oh, my IBS is improving," and you hear it 5-6 times. Then you start to go to the mouse data and start to do experiments and tease out mechanism.
Yeah.
I mean, it's just fantastic. It's absolutely fantastic. So the first thing with the inflammation you mentioned, do you think that part of the reduced systemic inflammation has to do with the fact that, if you're eating within the time restricted window, and this is something, your metabolism is optimal during this certain time window. So the first time you take in food sort of starts these peripheral clocks in the liver, for example, which regulate glucose metabolism.
Yeah.
And if you don't eat within a window where you're most insulin sensitive and you start eating later, then you're going to have more inflammation because your blood glucose levels are going to rise, and it's going to cause all sorts of problems. Same thing goes with fatty acid metabolism, right? I mean, the intake of fat itself actually can inhibit the beta oxidation process, right?
Yeah.
So if you're eating within this certain window, you're affecting your metabolism, and that in turn would then affect inflammation, possibly. But
so there is also this idea that there is some amount of gut leakiness, and so some of the bacterial proteins or bacterial membrane component, for example, LPS, and few other things can leak through our gut lining into circulation, and that can elicit immune response. But we know that with time-restricted eating, since our gut repairs itself at night for us, then during fasting time, the gut has enough time to repair so that the gut leakiness goes down. So in that way, our immune system is actually less exposed to these antigens that might leak through the gut.
Right.
That's another way that inflammation
absolutely.
can go down.
I remember a colleague of mine who, his name is Mark Shiganaga. He was a former colleague of mine when I was doing a postdoc with Bruce Ames, just a brilliant guy, gut expert. And he was telling me all about, I remember him telling me about how the gut can handle a high-fat meal the best early in the morning.
Yeah.
And because of all this repair mechanisms and things that are happening, like the first thing in the morning, it's better to eat. He was saying your high-fat meal was more, your gut could handle it better than it could like later on in the evening. So it's kind of interesting. But the LPS leakage and all this, very relevant for inflammation. The gut's one of the major sources of inflammation.
Yeah.
So the gut is also, on a circadian rhythm, and not just the microbiome, but like the goblet cells in the gut, and the ones that are making the gut barrier, and all these cells are on a circadian rhythm.
Yeah.
So it really does make sense that you want to eat within a certain time window for the health of your gut.
Yeah.
Right? I mean,
means health starts from the gut. Means our interaction, when we say health is a product of our nature versus nurture, or our environment, one of the biggest interaction with our environment happens in the gut through our food, and how the food is digested, how the microbiome handles that food, digests it and sends it to our system. So that's actually the interface between nature and nurture. So what happens there has huge impact. And we're actually finding that the entire gut lining from esophagus all the way to cecum is strongly circadian. There are many transporters, there are many pumps, even the channels that absorb drugs and get into our liver. Many of them are strongly circadian. And over the last 2 years, there are also many papers that are coming out showing gut microbiome composition itself is circadian. So that means the bug in our system when we go to bed are very different from we wake up with a different set of bugs in the morning.
right.
And this diversity is much more important because different set of bugs have their own specialization. So they break down or process different kind of food, or they also offer different kind of benefits. So in mouse experiment, what we have seen is when mice eat a standard diet, a healthy diet, and they eat on a regular rhythm, so they eat mostly during night time because they're nocturnal, and eat less during daytime, then their the microbiome composition changes nicely in a rhythmic fashion throughout the day. But when they eat this high-fat diet continuously, then that diversity goes down. Their gut is mostly populated by few major microbes. And then when they eat on a TRF fashion, when they eat only for 9 to 10 hours, then some of the minor species that are almost obliterated under constant eating, they slowly come back and they start to work. So we see that diversity component slowly coming back under
without even changing the composition.
Without changing the composition,
wow.
So the diversity comes up.
Yeah. That's amazing. Do you know if shift workers have a higher incidence of like IBS or gut issues? I mean, there's certainly a higher incidence of obesity and metabolic syndrome.
Yeah, so the shift workers always complain about gut issues. So gastrointestinal problem is the first thing they always complain about. So it makes sense from our mouse study and also from what we know from shift workers that circadian rhythm or circadian eating pattern will have a huge impact there.
Yeah, also makes sense in what we know from how the gut microbiome also affects the way we're absorbing nutrients.
Yeah.
And that it would affect obesity as well, right?
Yeah.
So that's been shown. So maybe there's also a link to that.
So I think on a daily basis, like for example, on a daily basis, what we feel healthy, another definition of healthiness while going to bed or night is not to have this acid reflux or heartburn, which is essentially a gut proton pump working differently. And what we find in mouse study is this expression or the level of this proton pump goes down under time restricted eating. So this is one example where many of our my circadian clock users reported saying, oh, well, you know, the first benefit we found is our acid reflux has gone down. We don't get that much heartburn. And then we got curious. We went back to what are the targets of all the acid reflux drugs, and we found this proton pump. And interestingly, this proton pump expression goes down in mouse gut.
That's awesome.
This is another example where we would never ask about. We don't have even a means to ask what is acid reflux and heartburn in mouse. But we have a means to actually get this response from users and go back and ask the mechanism in mouse.
Yeah, it's great.
Yeah.
I've never, the first time I experienced acid reflux was during my pregnancy, late pregnancy, when my husband and I went out and had some like fancy meal, and I usually don't ever like eat sugar or dessert, but I had like a little thing of like ice cream with some like chocolate or something. And we were in a hotel, and then we went to bed not long after. And I couldn't believe how unbelievably painful and uncomfortable it was. I've never had it in my life. But apparently, when you're pregnant, it's a problem because know your stomach's getting squished. But anyways, I decided at that moment, I'm like, I'm not eating out like that again because I don't want to experience. But I've heard about so many people talking about acid reflux before, and I never really knew. I was like, oh, so what? What is it? Like your stomach's upset.
Yeah.
No, it's really, you can't sleep.
Yeah.
It's like burning. Like you're just like something's coming up, burning. It was awful. I had to I couldn't sleep. I had to sit up for like a couple of hours, and so that the fact that TRE seems to be affecting, acid reflux and, through this specific proton pump inhibitor in some people using your app is like super cool.
Yeah.
The shift work is, so back to like the shift work and stuff, because a lot of people have reached out and asked that are, I think it's something like 20% of the US are shift workers, is that right?
So in the US, 20% of the workforce is shift worker, but at the same time, there are many who may be shift workers, but they are not counted in Department of Labor Statistics. For example, nowadays you can include the taxi drivers or Uber drivers or Lyft drivers because they don't classify themselves as shift workers. They might have a one regular job that they list, but then in the evening and weekends or early morning they are kind of doing the second gig, and they don't list themselves. Then another thing that we came up with is what we call second-hand shift workers. So these are the family members of shift workers who have a lifestyle that are very similar to shift work. And this is something that we found in a study in the same My Circadian Clock study in India, where we found some people who self-described them as not shift worker, but then their eating pattern was like shift worker. So when we asked them again, then we realized that their spouses were shift workers, and to maintain that strong family bond, they wanted to share meals with the shift worker spouse. So in that way, we call them the second-hand shift worker, who are not working in shift, but they are actually sleeping and eating like shift worker, and they may be experiencing the same adverse metabolic consequences of shift work.
Right.
So in that way, the actual number of people, fraction of population who are experiencing shift work-like phenomena for a few months or years in their lives may be upward of 30% or 40%.
Wow, that's a lot of people.
That's a lot of people, because in India and China, the card-carrying shift workers in workforce can be around 27 to 30%. And then you are there, a fraction of them have family members who are like shift workers because they are second-hand shift workers. So it can be upward of 30%.
And some of the negative consequences that are pretty, I would say, scientific consensus that's associated with shift work, what would be like the top few that you would say? Like,
yeah, so cardiovascular disease is right on the top, and then obesity, diabetes, and actually the very early study on shift work and metabolic disease was linking shift work with diabetes and obesity. And then slowly we started to see that in many of the longitudinal studies with nurses or with health professionals, just random eating pattern and shift work increases cardiovascular disease risk. And then recently I came across this very interesting piece of data that I was not aware of, that the number one cause of death and disability among firefighters in the US is not actually related to fire, it's cardiovascular disease and stroke. So that's the number one cause, not even fighting fire. So that tells us that all these chronic diseases are linked to shift work. And then there are also mounting evidence all over the world that shift work is tightly linked or increases the risk of certain kind of diseases, certain kind of cancers, including breast cancer. So that's why World Health Organization has categorized shift work as a potential carcinogen. So that's a very serious classification, because if we know that we have to stay away from carcinogens, even in buildings, if there is a carcinogen, there's potential carcinogen used as a paint, or there is a reagent, then we have to put a sticker. And just think about shift workers, they are actually doing something that's a potential carcinogen. They do it almost on a daily basis for many, many years. So that's why I think now there is increasing awareness how to manage shift work so that they will stay healthy and will reduce the risk of disease.
And they're doing something beneficial. I mean, firefighters, nurses, you know, police. I mean, they're helping society. So it's not like you can just eliminate shift work, right? I mean,
no, actually,
we need shift work.
Our modern society is actually based on those heroes. So we actually call them the guardians of our society, because they are the ones in the middle of the night, they are making the economy running. They are the ones who are hauling trucks, long distance trucks, and they are the ones who are actually transporting cargoes over plane or ships. They are the ones in the middle of the night, they are taking care of our health and to any emergency. So we have to kind of make sure that these heroes are healthy. So right. we have to kind of start thinking how to come up with a healthy heroes program where we can clearly say these are the lifestyles that they can adopt in addition to their being productive at work, so that they stay healthy. And one complexity with shift work is just not one type of shift. It's a mixture of many different types of shifts. And for example, firefighters may be on shift for 24 hours straight, whereas a nurse is on shift for only 12 hours. Whereas some of the fast responders may be on shift only for 8 hours. And then for some of them, the shift might change 2 or 3 times within a month. So they may be on a day shift versus night shift, even within the same week. Whereas in some departments and in some professions, they can be on same shift for 3 to 4 months, which helps them to adapt to that shift. So in that way, I think it will be interesting to bring up this heterogeneity in shift work and figure out which kind of shift work is more manageable than others, and perhaps figure out how we can help firefighter kind of shift work versus nurses kind of shift work and fast responders.
Yeah. Do we know from any animal evidence, for example, if you take an animal that is, you know, for example, nocturnal, like a rodent, a mouse, which usually eats at night, you force it to now not eat at night, but to be awake during the day and eat at day and not eat at night. So if you can shift them to a not eat all day, all night, but eat just within a time-restricted eating window, do we know if they eventually adjust, how long it takes for them to adjust? Does their metabolism adjust? The circadian rhythm adjust?
Yeah, so those studies have been done, and there are many different ways to look at it. One is if we just give the same unhealthy, high-fat, high-sucrose diet, instead of giving them at night time for 10 hours, for example, give them during daytime when they're not supposed to eat, when they're supposed to sleep. So the bottom line is, if mice eat randomly, then any kind of time-restricted eating is better than that random eating. So even if they eat during daytime for 10 hours, that still gives them some benefits. So it's still beneficial. So there are some constraints with animal experiments. One is, if we feed animals during daytime, they don't definitely they lose some sleep and they just eat. Unlike shift workers, they are actually not working throughout that daytime unless we force them to really work. So then it becomes a 2-factor intervention. Mm-hmm. And then at night time, when they actually go back to their normal activity, they run around in the cage. So in that way, they get a sleep deprivation factor into it. So they are not as healthy as night-fed mice, but at the same time, they have a strong sleep deprivation factor. So that's why I think among shift workers, coming back to shift workers, if we can control for how much they sleep during their off time, if they can sleep enough, if they come up with some sleep hygiene and adopt some sleep rituals that helps them, and then they adopt the eating pattern that best suits their shift, then it might help.
But eating
within,
still within a more narrow window.
Yeah, still eating within a narrow window. Yeah. Then there is another piece of unrelated evidence that daytime eating of a healthy food is still beneficial, and that comes from the area of caloric restriction studies in rodents. So historically, many caloric CR studies in rodents were actually done in a way where the CR mice got their food during daytime. And in most vivariums, the animal technicians come around in the morning, and then the CR mice get their food around 7 or 8 in the morning, and sometimes even up to 9 or 10 in the morning. And the caloric restricted mice actually eat all their food within 2 to 3 hours. So they eat. The
so
CR
they wake
mice
up and just eat because they're hungry?
Because that's when they have food, access to food, because the animal techs actually give them food. And so they don't sleep throughout the day, and in the evening they eat. They actually eat right away. So we know from CR studies that all CR animals, most of the CR studies in rodents show tremendous health benefits, even though they eat the food during daytime.
Wow, I didn't realize that was done that way.
Yeah, so
so maybe another layer of complication could be not only just time-restricted eating, but eating less as well?
Well, so one caveat is, in the CR study, the ad libitum fed mice were fed ad libitum, so that means they were eating at nighttime.
Oh.
So they were never controlled to eat during the daytime.
Oh.
So I think those are the new type of studies that need to be done, but at least we know that if the animals, we reduce calorie and fed them during daytime when they're supposed to sleep, it doesn't have any adverse impact. It actually gives them a lot of benefit. Now the question is, if we give them the same number of calories as our limitum-fed mice during daytime, what happens? And we have done that experiment not with standard diet, with high-fat diet. And with high-fat diet, they are better than at limitum-fed.
Right. So, okay.
So I think for shift workers, if they can constrain to certain number of hours, that's better. If they can improve nutrition, that's still better. They can reduce calorie, then that will be again better. So,
and if they can sleep, do things to help them sleep better. During the day,
during their
dark,
off time.
Quiet, cool, all the things that help you sleep. So that there is sort of some hope, possibly for shift workers, and maybe that as more data comes out through your study with My Circadian Clock, and also as you get data from My Circadian Clock app and then go to animals and look more mechanistically, things may come out even more. Another sort of question that sort of relates to this is, and people ask this all the time, is what about people that start eating later in the day? For example, they wake up 8 in the morning, but they don't eat until noon. So let's say they eat their first bite of food at noon, and they stop eating at 8 p.m. So that's 8-hour TRE eating window, and they go to bed by 11 or so. Do they still have the same benefits, or are they losing because it's like the circadian, the time restricted eating window is kind of shifted to later, and obviously there's a light darkness component to all this to some degree. So
those questions we haven't even teased them in animal models, but I'm sure some people will start teasing them apart. So what happens is, in the morning, we know insulin sensitivity is at its best. So people who have a bigger meal earlier in the day, they have less insulin spike, less glucose spike, etc. Having said that, we don't know for people who are starting their food every day at noon, whether their best insulin sensitivity is at noon or it actually happened at 8 o'clock in the morning. So that information we don't know. So this is where some study is needed in human volunteers who are doing this. And maybe some people who are starting to eat at noon, one day they can drink a glass of juice at 8 o'clock and prick themselves and get a glucose reading and monitor themselves. And then another day, a week later at noon, they will eat the same glass of juice and prick themselves and see how is their glucose response. So that's a simple self-experimentation with some healthy people. If they're out there, then they can do that. And if they post it, that will be really nice. Second thing is what happens toward the end of the day or night. So this is where it becomes a little bit complicated, because as you said, there is day and night transition. And we know that in the evening, as our body prepares to sleep, our melatonin level begins to rise. And that melatonin usually rises 2 to 3 hours before our habitual sleep time. So if somebody is going to bed around 11, then that melatonin is beginning to rise around 9 o'clock. On an average, for some people it might rise around 4 hours early, and some people it will rise exactly at bedtime. And when melatonin rises, there is new data showing that melatonin can bind to its receptor in pancreas, and this engagement of melatonin with the pancreas receptor essentially tells the pancreas, okay, it's time to sleep, you don't have to bother releasing insulin. So in that way, what happens if somebody is having a big meal when there is high melatonin, then there may not be enough insulin released from pancreas, and glucose may stay high in the blood circulation for a long time. And this study, these kind of studies came to publication because almost 10 years ago, large genome-wide association studies found that people with obesity or diabetes might have a mutation in melatonin receptor, and that was confusing because what is melatonin to do with obesity and diabetes? And you fast forward 10 years, people went back to the drawing board and looked at where the receptor is expressed and what it does when melatonin is engaged, and then they found out that there is this effect of melatonin on insulin. So that's why people who are eating late into the night, they may not get the best benefit in terms of glucose control, because their glucose might remain slightly higher than if they had the same dinner 2 hours earlier.
If they're making more melatonin.
If they're making melatonin.
Yeah,
so it's very, so that's why I said it's complicated.
Yeah.
But at the same time, I would say eating randomly over 12 hours, 15 hours versus eating to this 8 hours, even that starts at noon, I will prefer the 8 hours starting at noon.
Right. So it seems like there's, in addition to, you know, the food, the timing of your food intake, so, you know, the first time you're eating sort of starts a lot of these liver enzymes and metabolism and glucose metabolism and all these things. In addition to that circadian rhythm being regulated by just the food intake, there's also this whole melatonin issue and the night daylight cycle, and, you know, when you're starting to make more melatonin, and all that complicates things as well. Yeah, it seems. I remember a study that was done where I think men were given the same caloric meal in the morning and the evening, and glucose was measured, and the blood glucose levels were much higher in the evening versus the morning. But of course, they could have been, who knows how long, you know, was the morning like 8 a.m. and then they were doing, you know, 9 p.m. or 7, who knows, like, what their timing window was, right? I mean,
the habitual meal. What was the habitual meal?
Right.
Means that's very well, very widely observed phenomena, and in fact, there was a term for that it was called evening diabetes. So a person might be healthy in the morning based on blood glucose. In the evening, if you do the same postprandial glucose tolerance test and then look at the glucose level, then maybe diagnose diabetic.
Right, yeah. Well, I think the other component to this would be the fasting component, right? So people think, well, I'm only eating within an 8-hour window, so I have a much longer fasting period. And I think that's maybe uncoupling some of these differences between time-restricted eating, being on a circadian rhythm, and fasting, intermittent fasting, prolonged fasting, all these, you know, there's so many different terms out there. That I think sometimes a lot of just all gets mushed together in one group, and it's like all the same. But it's not actually all the same.
No, it's not the same. So for example, even not having food in your system for 12 to 16 hours, whether it's fasting or not, that's debatable, because some people say, well, it's not fasting, it's not having food for 12 hours. I think that's where I would say not having food for 12 to 16 hours is not fasting, but maybe giving rest to your system, rest and repair and rejuvenation of your system. So when we think about fasting, two things come to mind: feeling hungry. And feeling hungry has many different connotations, many different intensity. So one sense of feeling hungry is, well, you might feel light, and then second, your stomach may begin to rumble a little bit, and then I would say that is your stomach is telling, well, I'm repairing myself. You are not actually really hungry, you are not getting low energy that you cannot get up from the chair or run or something like that. And then after several, maybe 1 or 2 days of fasting, or maybe after 24 hours of fasting, some people will get a headache. So that's a good sign that, well, your brain is not getting enough energy in its habitual, usual form, and maybe trying to signal the rest of the body that the body has to send some other form of energy, for example, ketone bodies or something. So in that way, fasting, if you're measuring fasting, if you're defining fasting in terms of ketone body formation above certain level, then that may kick in after 24 hours. Or if you have that threshold even much higher than fasting maybe 48 or 72 or even 96 hours before you see that level of ketone body. That can be your definition of fasting. So in that way, I think the way you define fasting will determine whether 24 hours, 48 hours, 96 hours, or even 12 hours or 16 hours is fasting. But the way we think, we kind of define how many hours your system should not have food is based on our daily circadian rhythm, because if you think about what are the key elements to being healthy, it boils down to three important things. One is sleep, and the second one is nutrition or food, and then third one is physical activity. And these three are interlinked with each other. So for example, if somebody is sleep deprived or didn't have sleep, then it's very hard for that person to do physical activity next day or go on a marathon. So these two are interlinked. Similarly, if somebody is eating for 15-16 hours and has a very heavy meal at the end of the day, then it affects sleep. It also affects physical activity. One cannot run with full stomach. So these three are interrelated. So on a daily basis, what we feel is having limiting food to 8 to 10 or maximum 12 hours helps to coordinate these three foundations of health to work on a daily basis and give us healthy benefit. So on a very simple sense, if I want to relate time restricted eating and then maybe long-term fasting, 1 day of fasting, 2 days of fasting, or 4 days of fasting, which definitely have much more benefit, then it's almost like taking care of your teeth. So brushing every day is like time restricted eating. That's the minimum one can do, and that's something necessary to take care of your teeth. But again, once in a while, maybe twice a year or 3 times a year or once a year, depending on how much you want to take care of your teeth, you want to go see a dentist. So that's almost like a prolonged fast one has to do once a year. So similarly, I do 4 to 5 days of water fasting only once a year, and that absorbs all the other sins with my feeding that I might have committed throughout the year. So in that way, I think the difference between time restricted eating and other forms of fasting is one can adopt time restricted eating as a true lifestyle, starting even from teenage or even toddler years, all the way through when you are 80s, 90s, or even 100-year-old. Whereas this long-term fasting, 2 days or 4 days of fasting, forget about even teenagers doing it. And some older people who are very fragile, they may not be able to do it. And you need medical intervention or some kind of supervision to do it. Many people who are slightly unhealthy, means even some diabetic who might go hypoglycemic after 10-12 hours, type 2 diabetic I mean, they may not be able to do it without medical supervision. So although those long-term fasting definitely have much benefit, and that has been shown in multiple studies, the need is that they can be practiced only by certain type of people at certain age and need more mental resolve, and it may not be a everyday lifestyle, whereas time restricted eating can be a everyday lifestyle.
That's a great way of putting it. Sounds like also you're saying depending on what you're looking at, what biomarker you're looking at downstream, that also can sort of define something differently. For example, if you're looking at autophagy or apoptosis that's happening, you may not see or be able to even measure it. Maybe it's happening, but you can't really measure it well until you're getting a more prolonged fast, like where you don't eat for 4 days. Whereas, obviously when you're not eating for 16 hours, if you're doing a time restricted eating schedule of eating within 8 hours and you're fasting every night for 16 hours, you're in a fasted state in a way. I mean, you're maybe it's not fasting, but your glycogen, your liver glycogen starts to deplete at like 10 hours of not eating, and like something like this, and your adipose tissue is releasing fatty acids, and you do start making some ketone bodies. You wouldn't necessarily be in a high level of ketosis or anything, but protein deacetylation starts to go down, and these NAD levels rise. So it's like depending on what you're looking at, I mean, these things do start to happen, like in between meals even.
Yeah.
So to some degree, you can be in a fasted state, maybe, and not be necessarily fasting.
I mean, it depends on where you set the threshold and whether people can reliably measure that say ketone body or even autophagy level went beyond that threshold. So what used to happen was most labs, vast majority of labs, they're not circadian labs. So they, and many of the postdocs and grad students and kind of the really the ground soldiers who are driving science, they might have different schedules. So what happens, they come to lab at different time, and then they might be doing the assay at different time without any control of when the animals were fed, or how long they were fed, or what type of food they had access to. And then even if the mice had 12 hours of fasting or 16 hours of fasting, one might get a result which is slightly higher than what it was without fasting with food. But it's not reproducible, because as we know in circadian rhythm, the same parameter can change over time, even if we measure just fasting insulin level in mice, for example, or fasting glucose level. That has a very slow, very small change. So in many cases, people might discount it as noise in their system because somebody did the experiment in the morning, someone did in the evening, their values are different, so they will say this is noise. So that's why people have come up with a longer fasting to see the threshold, to set a higher threshold that they can reproducibly say this is signal irrespective of what time of the day the postdoc or grad student did the experiment. But then in circadian lab, what we do, we are very careful about timing. So we will sample every 1 hour, 2 hour, 3 hours, the same animal over multiple days, 1 day, 2 days, or even sometimes 3 days. Then we ask a very simple question: does it rise reproducibly every day around the same time? Suppose, say, the ketone bodies do rise, and they may not go from 0 to 100, but they go from 0 to 10. Every day they go from 0 to 10. Then the second question is, what is the benefit of ketone bodies going to 10 from 0 on brain function or muscle function or heart function? It's possible that maybe your brain may not get much benefit, but muscle and heart are getting some benefit. And in that way, you can see that if we carefully monitor and then ask specifically what are the benefits, we can come up with ways where we can say even this 12 hours of fasting or not having the food in your system will create some amount of benefit for heart on a daily basis, or some amount of benefit for muscle on a daily basis. So that's why it becomes very difficult. What is fasting? What is autophagy? Can we trigger autophagy only by 12 hours fasting or 16 hours fasting versus 4 days of fasting? Because autophagy may go from 0 to 10, might benefit only 1 or 2 organ system, may not benefit 10 organ systems.
Does it go from 0 to 10? Like, for example, when...
Yeah, so autophagy, we have actually published papers showing that autophagy flux and autophagy gene expression does cycle on a daily basis. And it's directly regulated by some of the clock components. Some mice, genetically mutant mice that don't have these clock components, autophagy level is set high, or the autophagy level is set low, depending on which component you turn on.
Does it go up during the fasted and or resting period?
It does go up during fasting phase in liver.
In liver?
Yeah.
That's really cool. So I kind of got sidetracked here with this autophagy because I'm very interested in it, but because it's a part of the repair process.
Yeah.
And the thing that's so interesting is this repair process being, in the fasting state and, happening during the fasting state. And like you said, maybe there's a threshold where, it's like, obviously if you're fasting for 14 or 16 hours every single day because you're eating within a time restricted eating window, that's also going to have benefits. And now the threshold may be, you may have less of those benefits, so you're not cleaning up, you don't have widespread apoptosis happening where you're killing off all the damaged cells, but you may be clearing up some protein aggregates or something, every day, sort of on this steady state sort of level, which also is extremely important.
Yeah, it's almost like, if you have a carpet, if you vacuum it every day or every other day, then that remains clean. But at the same time, maybe once a year, you need a deep cleansing wet vacuum. But if you don't do that daily vacuum, or at least once in 2 days or 3 days, then that gunk will accumulate.
It's going to accumulate and it's going to cause damage.
Yeah, so that's why this daily cleaning, even though it's a low level, very low level cleaning of the system, that has a huge impact. That goes a long way.
Have you guys ever looked at like DNA damage or repairing any sort of challenge, like if you irradiate, like animals that are eaten, on a time restricted, feeding sort of schedule where they're eating their food, being fed their food, within 10 hours or so, and you challenge them
with radiation.
Can they like repair the damage better because they're fasting longer?
Yeah, so circadian clock itself has a huge impact on DNA damage repair and radiation damage repair. So a few years ago, we had done a simple experiment that got highlighted in National Cancer Institute website. That's a very simple, straightforward experiment. We always asked, we asked a very simple question, that is, how come humans' skin is always exposed to sunlight or UV radiation, and many people get skin cancer, but they never get hair cancer, because hair follicle has the most rapidly dividing cells. Okay. And so one would expect that they must be most sensitive to radiation damage. And if there is any radiation damage, that's where the tumor should start. And we rarely see that. So we went back and checked, and we realized that the hair follicles, balls, that base of the hair, actually has a very strong circadian rhythm. And every evening, that circadian clock repairs all the damaged DNA and make sure that the hair can grow back next morning. And then we asked, so what is the real significance in real life? So we took these mice and then did a simple experiment, that is, for many bone marrow transplant experiments, mice are irradiated and then their bone marrow is depleted and one can put the new bone marrow in. They get irradiated to the same extent as humans do. They don't die, they actually survive pretty well. And if we irradiate mice in the morning, 8 o'clock, then those mice lose 85% of their hair. And if we irradiate the same mice with the same dose at 8 o'clock in the evening, they retain 85% of hair. So it's a big, really black and white difference, because these morning irradiated mice essentially become bald very quickly. And the evening irradiated mice, they keep their hair perfectly fine. Now if we take a circadian clock mutant mice where the circadian clock is absent, irrespective of what time we irradiate the mice, they always lost hair. And of course the story was much more about which DNA repair enzymes are regulated by clock and how this clock works, but this is a very simple, straightforward experiment. And similarly, people have also shown many patients do go through partial hepatectomy, or people who have liver cancer, the part of the liver is resected and then the liver grows back. And in mouse experiment at least, if partial hepatectomy is done in the evening, then those mice recover much faster than those where the hepatectomy was done in the daytime. So that has inspired some people to think about this surgery time, what time surgery should be done, or irradiation should be done. So these are some just new ideas that have just come up in animal models in the last 5 to 10 years. So it will take some time to really get some traction in human studies.
It'd be interesting to figure out whether it's, the combination of, is it because they're, getting more rest during that time, during the evening, and then they're resting, or they're fasted and resting and sleeping, the combination of them all, or
so we know that the tumor grows slower in mice that eat only within certain time. So time restricted fed mice, if we just implant a tumor on them, then the tumor will not grow as much as if the mice eat randomly the same number of calories. And that also jives with another piece of data that came from Ruth Patterson's group, that women who fast for 13 hours overnight are protected from breast cancer.
They have like a 36% lower breast cancer recurrence incidence. Yeah. So that's really cool. I wonder if with at least the animal experiments where you're implanting the tumor and they're fed at a time restricted feeding schedule, then if they're having more apoptosis, more autophagy, more DNA repair, all these things are all sort of simultaneously happening because they're in a fasted state for longer.
Yeah.
Possibly.
So it's possible.
Yeah.
Yeah.
Very, very cool and interesting. The other thing that sort of on this whole fasting versus TRE topic that gets asked a lot that I have to ask you has to do with coffee, actually specifically caffeine, like black coffee, so without any cream or any calories or anything like that. So caffeine can start things like clocks in your liver.
Yeah, it resets the clock. Means the clock is always running, it just resets
it. Okay. So a lot of people in the intermittent fasting community, they do a lot of fasting where they're fasting for 16, 24 hours, 48 hours, but they drink caffeine and they notice that they lose weight. And so they say, well, I'm still getting results.
Yeah.
So it's fine. I can drink my black coffee. And, obviously someone that's fasting for 48 hours, it's very different than doing a TRE schedule where you're eating for 10 hours a day or 11 hours a day and then fasting for, 13 or 14 hours every night, right?
Yeah.
So like for a person, for example, that wakes up in the morning, drinks black coffee at 7 a.m. They wake up, have some black coffee at 7 a.m. But they don't eat anything. They don't eat their first bite of food until
10 or 11.
Something.
Yeah.
Then when do they have to stop eating by? Like, is it when the coffee started or is it when they ate the food?
Yeah, so this is a question we also get through the app a lot. And we actually posted a blog on our website. So here is a very different thing. So since we look at circadian rhythm as a whole, it has a sleep component, food component, exercise or activity component, and we know that caffeine resets the body clock. So for example, drinking a cup of coffee is similar to having exposure to bright light for an hour or hour and a half. So that's just on the circadian clock itself. Now the question is, well, will it reset that clock the same way if the coffee comes in the morning versus evening or night? And we know that there is a term called phase response curve. So that means the same light, it relates to light. The same light will reset the clock differently at different time of the day. During daytime, when your system is expecting light, if you're in the dark room and we see light, it doesn't reset our clock. But in nighttime, it will reset our clock. So we don't know what is the phase response curve for coffee. Whether it resets much more at certain time and less at other time, the direct impact of coffee on clock is unknown. And the second thing that relates to coffee is sleep, because coffee definitely suppresses sleep in a lot of people. Some people may be resistant. And the reason why we drink coffee is we wake up, we get up from the bed, but we may be still feeling sleepy. We want to get that extra energy. That's why we drink coffee. And along that line, of course, drinking coffee at night is a straight no-no for because it will have impact on sleep. But in the morning, we ask the other question: are you drinking coffee because you did not rest well? You did not rest enough, so maybe that's why you need coffee to reset your mental clock or brain clock to start it. And sometimes it can be just a pure habit or addiction. For example, absolutely. I used to like coffee in the morning, and then I realized, well, let's get rid of coffee. What happens? Maybe for first 2 or 3 days I got a headache, and then now I'm used to drinking just hot water. It's just the feeling of sipping something from a sippy cup. It's almost like a baby sipping something from sippy cup. And I realized that that's what I was addicted to. I can actually substitute coffee with hot water and nothing changed. I still felt energetic after my hot water. I realized that was my addiction.
After you got over the...
After I got over the first 2 days of headache, withdrawal symptom. And then the third is the question of metabolism. When we drink coffee, is it going to trigger metabolism or certain things in our gut, so that the gut will think, well, now I have to start working. The rest is over. And we think that's where the metabolism or the function of the gut to absorb or digest this coffee, send that caffeine to liver and then to brain, does kickstart right after we drink coffee, because that's how we are feeling the effect of coffee in the rest of our body, because the stomach started working, it absorbed coffee, it sent it to liver might have metabolized it slightly and started to send it to the rest of the brain and body, and then it gets back to kidney, gets metabolized and excreted. So then the question is, forget about circadian clock. Now if we think about just metabolism and say mitochondria function, or even say go back to autophagy, and then ask, is caffeine breaking the fasting so that it stops autophagy, or it stops something else? Is there a crosstalk between, say, caffeine receptor and glucagon receptor, so that it tells, no, fasting is kind of slightly over. You may not be in 100% fast, you're in 40% or 50% fast. So that's where things become murky. So that's why we say, well, if you can drink your coffee within this 8 hour, 10 hour, it's better. But at the same time, we know, going back to the study that we discussed, Ruth Patterson study, they did not consider coffee as food. So when they considered 13 hours overnight fasting, that 13 hours actually included coffee and tea. So in that way, for cancer, reducing breast cancer risk, this 13 hours of fasting can include coffee, black coffee and tea. So this is where things are really murky, and we tend to err on the safe side. So we tell, well, if you can have that coffee within your eating window, that's much better. If you can't, then just have black coffee. At least that will not trigger your insulin response or glucose response. So that's what we do. Great. We recommend.
Just sort of as a side note, because you mentioned it, I recently spoke with Dr. Guido Cromer, who's an expert on autophagy, and he was telling me about a study he had published a few years ago where the specific polyphenols in coffee, decaf or caffeine, so irrespective of caffeine, it was the polyphenols, they triggered protein deacetylation, which is one of the triggers for autophagy. So it actually increased autophagy.
So that's why we never know, because there's coffee or any natural compound has so many different ingredients that we don't know their activity. And many of them can have very different effect. Means when you think of food, we are mostly in the nutrition science, or most of the scientists are latched onto the effect of protein, carbohydrate and fat. We discount a lot of xenobiotics, and actually our food is, majority of it is xenobiotic, and we have no idea what do they do, either alone or in combination.
And that actually, that's another question. I printed out some, but that is a question that's frequently asked by people in the audience, is like things that are xenobiotic, like herbal tea, even I guess to some degree people are asking about flavored water. So water that would contain, for example, like stevia or something, does that start the clock? And I think you've kind of answered that a little bit.
So in that way, means it may not start the clock. And also for your insulin response, it's not actually triggering the pancreas to secrete extra insulin. Insulin is an anabolic hormone, so it's not actually putting our body into a strong anabolic drive. So in that way, in many ways, it's okay to have this non-caloric containing food. But then it gets murkier once we go to, say, Diet Coke or something else where there is artificial sweetener, and then we know that the artificial sweetener have an impact on gut microbiome, and that's where things become murky. And these are very practical questions, but at the same time, we don't foresee that even there will be any controlled clinical trial to assess the effect of these nutraceuticals or even things that we take for granted on a daily basis. So this is where again the N of 1 experiment, self-experimentation on yourself, trying different kind of behavioral intervention where you switch from water to flavor water, and does it make you feel different? I mean, it's not only weight gain. One has to assess sleep, activity, feeling alert, feeling productive.
Maybe
and this
measuring your fasting blood glucose levels.
Blood glucose level,
that,
if you have a fasting, if you have a continuous glucose monitoring system.
Even better.
And so this is where strongly this self-experimentation by informed citizens who are very careful, they're not really, they don't have any adverse metabolic disease. And again, I'm not promoting that one should start doing self-experimentation, but at least whatever they're saying, they should share, because these are the things that
share it with my circadian clock. You guys have.
So even if they put some notes in the feedback section, then we'll compile all of those, and then that will help us to take informed decision about animal experiments. At least we can go back to animals and say, at least in animals we have tested this. This is how it works.
Right.
And in future, maybe that will trigger some.
Or maybe you'll get 10 people that come back and say, "Oh, I started drinking my, Diet Coke out in my fasting window, and all of a sudden my blood glucose levels started to get worse."
Yeah.
And so you'll have multiple people telling you this. Well, maybe there's something to that.
Yeah.
But people are asking about things like even supplements, and I think again, you've answered that. We don't, are you taking fish oil? Is it a fatty acid? I mean, maybe there's lots of things here, because that is, if you're taking a fish oil supplement, then what do you think that's different than taking, for example, vitamin D or?
Well, it's the question of, I like this kind of, I like to compare this to, say, physical activity. Somebody is completely sedentary. For that person, going for a walk, whether it's in the morning or evening or midnight, doesn't matter, because this person is getting some benefit of physical activity. Similarly, if somebody is very low on vitamin D or needs that fish oil supplement, then what time the person takes doesn't matter, because that deficiency is getting corrected.
Yeah, that's true.
So that's true. But then if someone now dials it slightly higher and says, well, I want to have this protein drink that's 25 grams of protein after my exercise late at night, is it okay? Then that's where I will say, well, then that's going to
probably not
affect your gluconeogenesis and muscle recovery. And maybe if you have done a very strenuous exercise, if you're training for like Ironman or something like that, yes, you have to have that.
So that was actually
a
question. I think someone was asking about weight training at night, if that would counter, if they, eat late at night after weight training, if that would counter. And I think that's kind of pushing it a little bit.
Yeah, that's pushing a little bit. And again, it depends on your training schedule and other stuff, what you want to get the most out of it. Like, for example, if you're used to training late at night and having that protein and carb drink right after that, what if you do a little self-experimentation and move that to, say, 5 o'clock or 6 o'clock and see whether it actually helps you do one extra push-ups or go for another 5 minutes, or is it actually compromising your performance? So it's very personal. And then some of these very kind of athletes who are pushing themselves to the limit, they want to squeeze the last drop of performance out of it. And for them, I think self-experimentation is the best way, because there is no way we as scientists, we can do that kind of study in our labs with a number of subjects who are as competent as them, and then controlling for everything. So it'll be very difficult.
But you did show in one of your animal studies that a shorter feeding window for these animals, like for example, 9 hours, or it was 8 or 9 hours.
8 to 9, both of them.
Endurance
performance
went up. So you do have some evidence of being able to squeeze the last drop of performance, maybe.
Yeah, so that we clearly see when endurance went up. And the reason why we did that experiment was we thought, well, if the mice are feeling fasted for a long time, will their athletic performance or muscle performance go down? Because our worry was their performance, athletic performance might go down. And in that way, it might be harmful for some people for whom physical activity is needed. And for example, many shift workers, they need that physical performance.
Right.
That's why we did it. And we realized that their grip strength, which is similar to how much weight a person can lift, that did not change, that stayed the same. But the endurance, being on the treadmill for a long time, that actually significantly increased. I mean, in some cases, it doubles. So, yeah.
I've noticed this in myself. I've done like 8 or 9 hour eating schedule, and the next day, so if I'm fasting for a longer period, the next day I go for a run in the morning.
Yeah.
And my endurance is, and this is, I mean, we're talking like 5 or 6 times, maybe 7 times I've noticed it. I mean, it's a clear pattern.
Yeah.
My endurance is dramatically improved.
Yeah.
I mean, it's incredible. Like, I just can keep running. Like, whereas usually I'm tired and I reach the mark where I'm like, okay, this is it. Finally, I'm getting, you kind of sprint to the end, and no, I just keep going.
Yeah.
And
no, we see that there are many people who have given us this feedback that their endurance does go up. And then what is interesting is, again, the endurance improves, and then once in a while they say, well, I can go back to 12 hours. And then immediately they see the reversal of that endurance.
Right. It does, exactly. It totally reverses, yeah. I know there's been some recent studies coming out in the last year or so where exogenous ketone bodies have been given to endurance athletes.
Yeah.
And it improved their endurance capacity, which makes sense because endurance is very heavily relies on mitochondria. Yeah. Right. So I mean, it completely if that's actually part of the mechanism with time restricted eating in terms of a longer, faster period, one would presume would have higher levels of ketone bodies.
Yeah, we do see they have slightly higher level of ketone bodies.
Mm-hmm.
This
so it makes sense.
Yeah.
Whereas, well, I don't know what exactly you're doing with the grip strength, but it depends on whether or not you're pushing them to a high enough intensity where they're becoming glycolytic or not. I don't know. Maybe not.
So again, we don't know what is the dynamic range of that particular assay, and we can't ask questions to mice. So this is where people who are actually lifting weights or doing something very different kind of exercise, endurance exercise versus intense exercise, those are very different. Maybe they can give us feedback to see what happens.
Now in your study, wasn't there improved lean muscle mass? Or?
Yes, we did see lean muscle mass improvement only on mice that were given standard diet, not on high-fat diet.
Okay.
The high-fat diet-fed mice.
I wouldn't expect for them. So they were given. So the mice that were given the normal, sort of standard healthier diet, and were given what was their eating schedule?
They were 8 to 9 hours.
So it was a shorter time window they were eating. They had increased lean muscle mass. Now, is that something like? Do you know why that is? Has that been looked at?
We actually don't understand that. That's another thing. No, but we do see there is increase in PGC1 expression in muscle. So there might be increase in mitochondria function, but we do see, but surprisingly in the same mice we saw there is less glycogen in muscle, and that's kind of counterintuitive. You might think that, well, the muscles may be loaded with glycogen, so that's why their lean mass went up, but at the same time what we think is maybe because they have less glycogen, we know that if the muscle has less glycogen, then after normal activity, then glycogen may be completely depleted, and when they eat, they have a much better feeding response. So that means a much better glycogen synthesis response. So they may be making and breaking glycogen, making and breaking triglyceride on a daily basis, or protein on a daily basis. So in that way, I think they may be maintaining much better muscle health. Because they're also going through some gluconeogenesis, they're breaking down some protein. So maybe some of the structural proteins that get modified and maybe they get damaged, they're kind of getting cleansed. They're getting cleaned out of the system by this eating and fasting rhythm. So it's all speculation. So we have to go back to the muscle.
Yeah, you have the data. You just don't know the mechanism.
We don't know the mechanism.
But and it's very people are very interested. I mean, increasing lean muscle mass is hard to do, and there's a lot of huge interest in it. Huge interest.
Now, actually, we have been seeing this reproducibly in multiple strains of mice, and it happens with a balanced diet. So this is where the nutrition quality does
play a role.
Which makes sense. So we can't expect people to eat the same fatty food and expect the muscle mass will increase.
Right. Yeah. So there's a nutritional component to it in addition to eating within a restricted time window, which completely makes sense.
Yeah.
Some of these other questions that are just frequently asked, a lot of people just really they want to do time restricted eating and they want to do it right.
Yeah.
And so that some of these questions can be a little silly, but it just shows how people are thinking. Like, for example, does toothpaste start the clock?
If you're not swallowing, maybe it's okay.
So if you're not swallowing it, probably not starting the clock.
Yeah, it's not starting, it's actually resetting the clock. So I think we have to also think of time restricted feeding, although we came from a circadian clock lab, so that's why we always get connected with circadian clock. But time restricted eating has also feeding, fasting, that whole physiology tied to it. So the other way to ask the question is, does brushing your teeth or mouthwash break the traditional definition of fasting? And definitely it's not breaking that. It's not putting food in your stomach so that the stomach will start processing it and insulin starts going up slightly and blood glucose going up. So in that way, we have to keep in mind that we have to bring that definition back once in a while. No, it does not break that fast.
I think that's a good way to explain it. Some other people we talked about the night shift work and so that was good. And you also mentioned another thing people are asking about is when can you start a TRE schedule in a person's life, like developmentally?
Yeah.
Can you start as a toddler? Is that too early? I mean,
I think, so we know that in newborn, the suprachiasmatic nucleus is not even fully developed, and it may not be even fully connected to the rest of the body. And that makes sense because the babies are going through a very rapid growth phase. And what they need at that time is a lot of nutrition and growth. So TRE may not be desirable at that time, not at all. In fact, since it can trigger adverse effects, so I won't recommend. I think the rule of thumb is when babies or toddlers begin to sleep 8 to 9 hours continuously through the night, anyways, now their physiology or their sleep pattern is already getting used to being without food for 7 to 8 or maybe 9 hours. And that may be a time when at least one can begin the first phase of time restricted eating, that is to start with a scheduled or well-defined morning breakfast time or the last meal or even bedtime. So recently there was a study done in England showing that babies were having a very regular scheduled bedtime and also last meal are protected from childhood obesity even 5, 6, 7 years down the road. So although they did not measure when these babies were eating and all that stuff, what I think is having a regular bedtime itself is a very strong timing cue that these babies are going to bed at a certain time, and most babies will sleep for 8, 9, even 10 hours. So they're already into 10 hours of fasting just through their sleep. And then it takes an hour for them to get up and then get ready and then start eating. Or for some babies, they may finish eating and then they're reading a book or something and somebody's reading them a storybook. So that you'd add that 1 hour between the last food and going to bed. So in that way, I think the rule of thumb would be when babies start to sleep for 8 to 9 hours continuously, then that would be a good time to start putting them to bed at fixed time. And then the next thing would be giving them breakfast at the same time every day, or having the last meal or the dinner time fixed. So then their body gets used to it. And then by the time they're in elementary school, it'll be easy for them to adopt a 12 hours eating time, and then if they want, maybe they can go down to 10 or 12, so that itself is a very good limit on them. So in that way, I think it's a very clear example that TRE is something that you can start very early on, and it can be a lifelong habit.
Excellent. Yeah. Excellent. Let's see, what are the other really common ones? Some people are kind of curious whether or not if anyone's looked at, or even if you have any thoughts about within your eating window, like, does it matter if you're having lots of frequent meals or you eat 2 meals? Do you?
Yeah, so that's a question that comes up very frequently, and actually this is where again I kind of go back and forth between what we know about metabolism and response to eating. And we know every time we eat a good amount of food, even a good sized snack, there is enough sugar in most of the snack that will trigger a insulin response. Our blood glucose will go up. It will stay up for maybe 90 minutes to a couple of hours, and then it will come down. So every time we eat, we essentially trigger our insulin to go up slightly. So there is this anabolic hormone going up and staying up for maybe 1 or 2 hours. So in that way, our body is getting into that fat storing mode every time we eat. So with that in mind, I would say the smaller number of meals within that 8 or 9 hours is better than eating every 1 hour within that 8 to 9 hours. But again, this is where we don't have hard data. It's just going by my prediction based on what we know from physiology. And this might hold true for normal healthy people who do not become hypoglycemic after 6-7 hours of fasting. Right. But we know that there are a lot of people who actually prefer to eat twice. And this is something that we find with many people who adopt TRE, that what happens is after 14 to 16 hours of fasting, they are hungry to have a good breakfast. And if they have a good breakfast with enough, say, protein, fat, and some complex carb, then naturally they will not feel hungry for 7 to 8 hours easily.
Right.
And then they have another dinner or maybe one snack in between. And essentially that has even happened to me. I eat mostly 2 meals, my big breakfast, and then I go to dinner, and it actually helps me stay productive throughout the day. I don't have to waste that 1 hour for looking for food, having lunch, and then the postprandial dip. So the short answer is less number of meals may be better.
The same thing for me. It depends on what I eat for breakfast, and I've noticed change. Like if I eat like a breakfast that's got higher protein, higher fat, I will be satiated for much longer. And as opposed to, or even higher fiber. As opposed to, for example, if I eat yogurt and some berries. Not good.
Not good at all.
I'll be hungry a couple of hours later.
The same thing with me. So.
So that's definitely not my go-to breakfast. But I also wanted to mention, because you were mentioning what we do know about metabolism and how even a small amount of food can trigger an insulin response and elevate blood glucose levels. Some people might be thinking, well, what if I just do like a ketogenic, just fat only, just eating fat? And the reverse of that would be also, I guess, if you think about metabolism, we know that a high-fat meal, if you're going to use that fat as energy, you have to, it has to be imported into the mitochondria. It undergoes this process called beta oxidation. There's transporters, carnitine palmitoyl transferases, CPT transporters. Those also are regulated by, guess what? Fat. Malonyl-CoA inhibits it. So you can eat that fat meal and then eat a smaller fat meal later, and that second meal will probably not be used as energy, but
Yeah.
stored as fat.
Yeah.
I mean,
So that's what happened.
Right.
And also another thing is, what do we find? A lot of people, it's very natural that some people think that a particular diet is rich in protein. That doesn't mean that it's only pure protein. So one simple example is, many people think that lentils are high in protein. So lentils, they can just eat lentils and they'll get protein source. But lentils have only up to 25% protein and 70%, almost 70% carb. So when they eat lentils, they're actually eating a very nice carb-rich and protein-rich diet, and that carb will trigger a good insulin response.
Right. Yeah. Great. Let's see what other ones that are really frequently asked. We talked about xenobiotics. Obviously, pharmaceuticals. If your doctor tells you to take a pharmaceutical at night, then
then you have to take a night, and your doctor overrides any other thing that you are self-experimenting.
And as we were talking about a little bit earlier off camera, xenobiotics themselves are on a circadian clock.
Xenobiotic metabolism is strongly circadian, and there are 3 or 4 major xenobiotic degrading enzymes. So actually, these are the transcription factors that control many of the cytochrome P450s that break down xenobiotics, and these are strongly circadian. And in fact, a lot of the circadian rhythm research, we use one of the xenobiotic regulators as a reporter, as a marker, because even the circadian clock components are not as robust as the xenobiotic metabolizing transcription factors and enzymes. So that's why. In terms of xenobiotics, almost every step of xenobiotic absorption, metabolism, excretion is strongly circadian regulated. And that's an emerging area a new area of circadian rhythm research. So that is what time of the day a medication may be better absorbed and most effective, because any medication that we take, it's actually going and interacting with a protein. In most cases, it's going and inhibiting or stopping a protein or activating that protein. What if that protein is actually not there? Then we are essentially taking a drug with no benefit, and the protein turns up. So, for example, we take the medication in the morning, but the protein actually comes to play in the evening. So then this medication has no impact, and then the doctor will keep on increasing the doses so that it comes to a point where there is some medication that's remaining at the end of the day. It will start to have its intended effect.
Wow.
But then the side effects, the adverse side effects will go up with the increased dosing. So that's why there is now there is a lot of interest on what time of the day a given drug target reaches its peak, and can we match drug timing with its target so that we can have the same effect with less of the drug, so that we can reduce adverse side effect and we can increase efficacy. So that's a whole new area of research that's going on. And the small or the most impactful statement about that is, recently people have found that nearly 70% of FDA approved drugs have their targets cycling in the body. So that means for 70% of FDA drugs, just timing can make it a drug or make it a poison.
Wow.
So that will be an emerging area of research in circadian rhythm.
Yeah. I mean, I'm very interested in this field. I think it's very important for that reason, particularly because so many people are taking pharmaceuticals. But I don't personally take pharmaceuticals, but I do take things like turmeric, curcumin, these polyphenols, which are xenobiotics. And I'm interested in, can I take my curcumin at a certain time of day and it's more effective? I get more bang for my buck, because it's metabolized quickly. So I would like to find, that time window. That would be kind of cool. So, okay. I think we've covered the questions that are pretty frequently asked. Yeah, great. So, again, this getting back to the my circadian clock, I think is sort of key, because you're aggregating data from all over the world, right? Yeah. You have people now from
So we have people from almost every continent except Antarctica. So
that would be cool.
If somebody is going to Antarctica, and really, if you're in,
I need to get some of the researchers that are on
yes.
the station over there,
yeah.
the research station.
And we haven't hit the International Space Station yet.
Okay, that would be cool too.
That would be cool because in ISS they're going through a 90 minutes day-night cycle because the space station makes one revolution around the Earth in every 90 minutes. So they see a sunrise and sunset in every 90 minutes. And they are the ultimate shift workers.
Right.
And we know that they struggle with it a lot. And recently the ISS is fitted with circadian lighting. So they will go through a simulation of light dark cycle, not a light dark cycle, but blue light enriched and red light enriched, that kind of cycle. So we'll see how it improves their life.
Yeah. So. That's really cool. For the data that you're aggregating, I guess, aside from people putting comments, which are probably extremely useful, you're learning obviously things like the IBS and all these things you're learning from people putting their comments. Is there any mode of tracking like cognitive function or mental function, or is it just the comments that you're kind of relying on?
So we haven't done anything. Actually, we are going to release a newer version of the app based on many comments that we received. Also, it will be a little bit more user-friendly, hopefully. So if we add more functionality to the app, then it becomes more complicated for a lot of people.
Yeah.
So that's why we have to find that balance where we have to kind of stop and then see the right balance, or maybe bring up some cognitive functions, or link our app to other apps that do cognitive functions.
I'm personally curious in whether or not time-restricted eating affects cognitive function, mental performance, and also just brain aging in general, because we do know that shift workers, for example, that have worked like 10 years or more, have like their brains age at like an accelerated rate. Their brains look like 6.5 years older than age-matched controls or something.
Yeah.
And I think there's some animal studies showing if you make mice eat when they're not supposed to eat, so when they're usually sleeping, so for them during the day, I think their like hippocampal function was like messed up, or long-term potentiation was messed up, and learning memory is.
Yeah, so there are many studies done. For example, in high-fat diet-fed mice, a lot of cognitive functions and social functions have been assessed. Mm-hmm. And we know high-fat diet disrupts their circadian clock, they eat randomly. So in that way, we know that there is already a deficit, there is already a problem with brain function. And now those kind of experiments will guide us to see if we give the same high-fat diet within 8 hours or 9 hours to mice, and we do the same assays, what will happen, whether we'll see improvement in benefit. So that's one set of experiment. The other set of experiments that will be very useful, and I'm sure somebody else must be doing it, because if I can think of an experiment, somebody else is already doing it. That's to take all these animal models of Parkinson's disease or Alzheimer's disease, and then put them on time-restricted feeding.
It seems obvious.
And then see whether the performance improves.
Yeah.
I'll not be surprised if we see this kind of studies coming out in the next 6 months or a year.
Well, surely, I mean, if you're clearing away, at the very least, clearing away some of these protein aggregates because you're having a constant fasting period, then if indeed those protein aggregates are affecting cognitive function, you would imagine that would be an improvement.
And also, what we know from sleep research over the last 3-4 years, one of the big things that came out from sleep studies in the last few years is we knew sleep improves learning and memory, synaptic plasticity, etc. But now we are learning that sleep actually improves cleansing the brain. So, for example, the xenobiotics and other stuff, the gunk in the brain gets broken down and is clean during this sleep time. And I would say that there might be some aspect of fasting, because, of course, in all these studies, the animals were eating less when they sleep. And so then the question is, how much of fasting contributed to cleansing the brain?
You're talking about the glymphatic system
The glymphatic
being activated.
system. And
that would be super interesting.
Yeah.
That would be very interesting.
So that's also another reason why we think that, well, maybe fasting is actually improving sleep by affecting maybe this xenobiotic metabolism or something else. So it's kind of interesting that we did a very simple experiment a few years ago, and now we have more questions than answers. And this is exciting.
Yes. Do you have any neurobiologists in your lab that would be interested?
Yeah, so we are collaborating with experts in this field who work on neurodegenerative disease to see what is the impact of time-restricted feeding on these mouse models. And of course, we cannot just take one mouse model. We have to use a multiple number of mouse models to make sure that this is, at least in mice, we can assess whether benefit or adverse effects on multiple strains, and then we can come to human studies.
I know the lymphatic system is like one of the major ways the brain clears amyloid beta plaques. Like you said, among other gunk and things, that's part of the gunk. I mean, so that would be extremely interesting to see if your eating schedule also affected that as well. Definitely no shortage of interesting things to ask.
So keep me busy for a while.
You've got a website?
Yes, I have a website called mycircadianclock.org, and that website has a lot of information as blogs, and also in the first page in the informed consent, what we do, we ask people to go through the informed consent to see what they are asked to do or what they may volunteer to do as part of the study. They may give us some information about themselves. And in that way, we can relate. As we increase the number of ends, we have more participants. We'll always have some participants who belong to a certain age group, gender, or socioeconomic conditions or demographic. So in that way, we can always figure out what is their existing lifestyle and what they tend to change, what they can change. And then after they sign up, they get the copy of informed consent in their email. So it's very important that you give a email address that actually works. We are not going to use the email for anything else, and we are actually overseen by a committee of ethics committee who reviews everything that we do. Any data that we, even in future, if we want to share, it has to go through that ethics committee. It cannot be given to any entity for profit. And so in that way, we maintain privacy very strongly. And then once they download the app and start collecting, one interesting thing is what we find. People hear about our study through podcast or other things, and they start doing time-restricted eating from get-go. So in that way, you don't get a picture of snapshot of what was their lifestyle before they adopted time-restricted eating. So one request is for the first 1 or 2 weeks, it's better if they just continue their current lifestyle. Even if they were eating in the middle of the night once in a while, it's better to have that in record. So that we can say this was, then people can themselves compare. This was my lifestyle before, and then after 2 weeks, when they set their new goal, or if they say, well, I can do only 10 hours of eating, that's fine, but 12 hours or even 8 hours, then we can compare how was life before TRE and how is life after TRE, and we can compare those two. And what happens is, yes, we ask to log a lot of different things. Some people do it and some people may not like to do it, but that's okay. If people can log at least one thing, whether it's sleep, whether it's food, then that's much better than not logging at all. And then another thing that we notice is some people will get into the habit of time-restricted eating for 4 to 6 weeks, and then they stop recording. And we know that they say, okay, I don't need this guidance, or I don't need to log this data. I can do it by myself, and that's fine. But for us, it'll be really nice if they can log at least the first and last meal for the rest for up to 12 weeks. Because all of these will help us to figure out whether you're actually falling off the wagon or you got it, so that you don't have to do it for 12 weeks. So in the next version of the app, or when we go to our ethics committee and ask permission, we'll say, well, we are finding that people get used to it in 6 weeks. We don't have to ask them to monitor everything for 12 weeks. So all these things matter. And then once in a while, giving us some feedback. If you see some improvement, please share with us. If you see any adverse impact, that's much more important. Please share with us, because then we'll know what are the adverse impact, and we can report that to our committee, and also we can go back to mouse and then see why this happened. And then at the end of 12 weeks, if people can record, say, their body weight or any other measures that they can record, then that will also help us. That will help us to go back to mouse, or even report, include in their final publications, because what we are foreseeing is we might begin to start publishing from the app from end of this year onwards, and there are many different ways one can dissect the data. So there are many different ways we can publish it. So the more information we have, what happened in response to TRE, the better it is. And maybe we'll go back and then have recontact with some of the participants and ask them after 1 year or after 2 years, or after 3 years, with permission from our ethics committee, can you tell us, are you sticking with this habit, or what actually made you not to stick with the habit? Because those things are also important. What are the other lifestyle factors that are preventing us to stick to a eating schedule? So we want to learn from people, and we want to kind of learn it the other way around. Instead of doing controlled clinical trial and taking it to people, we want to get from people's experience and then see what sticks, what doesn't stick, and then go back to basic science.
Right. What you're doing is fantastic.
It's the basic to bedside and then back to basic.
You're getting ideas. You're thinking about things you wouldn't have even known to think about. I mean, because
no, it's
getting
like
data, and it's fantastic. So I definitely encourage people to try
one of
this
the already published results that came from people's feedback is when we did this small time restricted eating study, where there are only 8 participants, but all 8 of them said they slept better. And we had never asked the mice whether they slept better. Right. So we went back to our Drosophila flies, and we saw that they were sleeping better. And then we went back and looked at the brain transcriptome to see why they're sleeping better. So this is one example where we went from a feedback to doing a basic science research in flies and actually publishing that data in Science, and then moving on to do more molecular studies.
Yeah, so maybe that will affect the lymphatic system if the eating does make you sleep better.
Yeah.
Right. So.
Okay.
And so you're also on Twitter. Your Twitter handle is
Satchin Panda.
At Satchin Panda.
At Satchin Panda.
And anywhere else? You got your website and your Twitter?
Yeah, website and Twitter, and then I'll start maybe Instagram or something.
All right. Well, let me know.
Yeah.
Thank you so much, Satchin. Always a pleasure to talk with you.
Thank you so much, because you are doing the right thing for science. Means communicating science to the mass. This is what we scientists cannot do, and we need people like you. Thank you. Thank you.
All right, guys, I want to mention 3 quick things. The first is that if you're interested in time-restricted eating and want to give it a shot, make sure to consider contributing your data to Satchin's study. You have to be 18 years of age or older, but it's now open up to international participation, and the basics are pretty straightforward. The first step is to submit a 2-week baseline by eating like you normally would, but logging it by taking a picture of it with your phone. This part is actually important because at this stage, you're just tracking what you would normally do. And when you take that picture with the app, it creates a timestamp for that thing you just ate or drank. For many people not deliberately practicing time-restricted eating yet, this initial baseline is a great way to find out that you're probably eating within something like a 15-hour window rather than a 12, 11, 10, 9, or even 8-hour window, and that you have room for improvement. After you do that initial 2-week baseline, then you have the option to pick a new eating window you'd like to try out and think you can stick to for at least 12 weeks. That's 3 months, which is about the time it takes to really lock in a new habit. That's it. You have the option to add in other helpful data as well as you go along. In particular, they really like to try to get your weight once a week, but by at least getting the minimum amount of data, especially a picture of your first and last meal and staying with it, you're really helping out Dr. Panda's group and probably getting a little bit healthier in the process. To sign up for Dr. Panda's trial, head over to mycircadianclock.org. That's Circadian, Circadian. Once again, mycircadianclock.org. The second thing I want to mention before we go is that this podcast is brought to you by listeners just like you. So if you like this podcast and think we're doing a great thing, head over to foundmyfitness.com/crowdsponsor. The best part about supporting the podcast in this way is that it's accessible to everyone because it's a pay-what-you-can subscription. For some people, that's going to be an amount that covers a latte, and for others, it might be a little bit more or even sometimes less. Basically, whatever it's worth to you. This helps us to make our content free or nearly as free as humanly possible, which means more people are able to be enriched by it. I am so thankful to all of you that helped me to be able to do that. For those of you participating, I try to throw in little perks like exclusive Q&A sessions sometimes and other odds and ends as well to make it worth everyone's while. Once again, if you like what we're doing here at Found My Fitness, you can get in on sending over a little pay what you can support by heading over to foundmyfitness.com/crowdsponsor. That's foundmyfitness.com/CROWDSPONSOR, crowdsponsor. Finally, one last mention. If you've done a 23andMe genetic test, they provide you with raw data you can run through other services. I have one on my website where you can learn about interesting genetic polymorphisms that affect metabolism, nutrition, and more. I'm continually improving this report, and I've also just added a few circadian-related polymorphisms recently as well. If that's interesting to you, you can check that out at foundmyfitness.com/genetics. Once again, that's foundmyfitness.com/genetics. Okay, that's all I've got. Thank you so much for listening. Until next time, I'm out of here.